I want to show you a whole bunch of ways of giving feedback to students, and I am a math instructor. Even though I'm a math instructor, I think any of these tools would work for anyone who is putting together some kind of assessment, assignment that's going to take place over a long period of time, and the students are going to need constant feedback and encouragement. The context that I do is I use projects. I don't have any exams in my classes. Some of these classes are fully online classes. Some are face-to-face, but they're assessed on the, I don't have tests. That's all there is to it. I didn't want to deal with the hassle of mailing exams around the world. So what happens is the students get a project letter at the beginning of about anywhere from a 3 to 5 week period, depending on the project. They have to go through a series of assignments where they learn some technology tools. And each one of the assignments, they usually are due one a week, they're going to get feedback on, and they'll be able to fix things and then move on to the next assignment. After about 4 or 5 weeks, they create a research poster, not quite like the ones that are in the back of this classroom, but professional research posters. And they put those out to be reviewed by other students. They get reviews. Then they come back, and then I grade them. So that's kind of the process that I go through. To really understand, though, what they're doing, you probably need to see a little bit of the kinds of things that I'm asking them to do. Most of you probably haven't had a math class in a lot of years. This is not the college algebra class that you took. So there's the feedback that I was talking about. Now I've got to give them feedback in each one of those areas. So my goal, this is the first project that I give college algebra students. I do similar projects in other classes, and they have similar goals, but the math's a little bit different. I want to introduce them to Microsoft Office as much as possible. We think our students are digital natives. They're digitally naive more than anything else. I want to give them an awareness of how math is used in the real world, not just manipulating symbols, that kind of thing. And I want to teach them how to document their work. A lot of these students may be in English classes, but this is a different type of documentation that they're not used to. And of course, I want to teach them some math. So here's their first project. It's a very simple project in a lot of ways, and a very realistic project. What I do is I give them some data for 2-year colleges and 4-year colleges of cost data. And they need to use that data to figure out if they went to community college for 2 years and then a 4-year university for 2 years, how much money would they save? And this data is over 2006 to 2010. They're actually going to be doing it in the future. So they're going to have to project some things into the future. Oh, and what makes this interesting, that data right there is for the entire US. Each one of the students have data from a particular state. So they're all doing the same project. How much do I save? But the difference is one student's doing Virginia, another student's doing Arizona, another one Washington. And so that gives me roughly 50 states to work with. Of course, I have more than 50 college algebra students. So what I also have is I have 4-year private colleges and 4-year public colleges. That gets me to 100 different projects that I can assign my students. How much do you save for those 4-year colleges versus taking a 2-year college for 2 years and then going off? So what they're looking to do is to create a graph that looks like this. The costs are going up, as we all know, and they all know this too. And what we're going to do is project farther to the right into the future and figure out what are the costs in the 4 years that they'll be going to college, and then what's the difference when you go 2 years versus all 4 years at the university. I'm going to try and minimize the amount of math here for my audience. So there's a strategy that they have to follow for this to work. They have to make a scatter plot. They have to graph that data. They have to find the line that passes close to that data. They have to graph that line with the scatter plot, like you just saw a moment ago. And then they have to calculate the total cost and the difference in the costs. So that's where they're headed. When I first started doing project-based learning, I kind of gave that to them, and 5 weeks later I gathered it from them, and it was a disaster most of the time. The best students could do well, everyone else had a hard time. So I realized, okay, I need to teach them some of these skills. So they're going to have to learn a little bit about Excel. They're going to have to learn some things about Word that they probably didn't know, like using the equation editor in Word. I can't do an online class without that. They're going to have to be able to use PowerPoint. So they're going to be putting tables into PowerPoint. They're going to be copying graphs from Excel into PowerPoint. Lots of things that even those students that have used PowerPoint have probably never done before. And of course, there's some math that we have to teach them. So I have to teach them about what is a scatter plot, how do you find the equation of a line that passes through 2 points, and another thing that's called function notation that makes documenting all of this a lot easier. So here's what the technology assignments are. What you're going to see on this page is basically what they turn in to me. So there is, they have to fill out, put the data into Excel. They have to resize columns, learn how to wrap things, a lot of formatting, and then they have to be able to create the scatter plots that you see right there. Now, they certainly can't do this all by themselves. So what I do is I document every single step that they have to go through. And so what you see, this is a part of the handout for Technology Assignment 1, where it's literally saying you need to grab this column border and move it to the side. Everything's there, and generally speaking, they latch onto that and they follow it step for step. In fact, they follow it so well that they often turn in the data that's in the handout. They forget to change it to the data they were assigned, despite the fact I tell them 5 or 6 times not to do that. Technology Assignment 2, you see pretty much the same thing, but now we've added on the straight lines. And so they have to learn how to graph straight lines within Excel versus data points. In that particular handout, it's showing here steps 16, 17, and 18, but it probably goes up to 30 steps that they go through. Little screen captures of everything they should be seeing along the way. In Technology Assignment 3, they actually take the graph that they've created, they paste it into Word, and then they start documenting down below it using the equation editor in Word. And again, there's a handout for that that goes through every single step to say this is what you need to do. And I don't have too many students that have trouble with the technology. Mostly it's, the math part of it, which is maybe counterintuitive to what you might expect. Eventually they take all of that work that they've been doing, and that's what they end up with, that's one of their research posters. This is actually when they create it in PowerPoint, it's 56 by 48, and they use monstrous size fonts because if we really wanted to print these things out on a real paper, they can do that. And I haven't had anyone do that yet, but they're working with PowerPoint the same way they would professionally. And they actually start from a template to do that. So this is where what I've been talking about so far, the way I think about it is if you're an English teacher, you want them to produce some product at the end of 5 weeks. There's certain places along the way you need feedback from them. It's the same thing here. At the end of each one of these technology assessments, I need some feedback. I need to give them feedback, and I need to see where they're at so they don't go off in some crazy direction like using the wrong data. So I give them very specific outcomes. This is what I want to see when you turn this in. And usually it's an Excel workbook or Word document that they turn in. I can usually look at that thing and grade it in 15 to 30 seconds. And then I need to start figuring out how am I going to get the feedback to them. Typically on a technology assignment, I don't try to give them individual feedback. I don't try and send them an email, although I say most of the time because later on I'll explain when I do that. What I do is, as I'm grading these assignments, if something is interesting that I want to show the rest of the students, I'll use a little screen capture utility. I'll capture that little portion of the assignment and I'll save it. and then I'm going to upload it to my blog website later on so that all the students can see the mistakes. Because remember, eventually they're going to be reviewing each other. If they haven't seen mistakes already, if they were to see these projects for the first time, they'd just say, oh, that looks beautiful, and they'd think it was an art class. But they have to see mistakes, and they have to understand how to find the mistakes, and the only way to do that is to show them the mistakes the students have already made. So here is a typical feedback that I give them. Some of them have not everything here, some have smaller parts, but this particular one is about Technology Assignment 2. There's a video at the very beginning of it. When I include a video, usually it is saying, these were a couple that were really good. Later on in that page, you start to see some screen captures there. So these were graphs that students turned in, and I had various problems with them, and so I said, hey, take a look at these things. This is what's wrong. This is what needs to be fixed, so everyone can see that. And you know, on this one, there's like 3 or 4 things that everyone has trouble with, and that's what's in this particular assignment, or this particular post. So here's the actual assignment here, and I'll go ahead and play a little bit of this video. When I make these videos, I try and keep them as short as possible, usually 5 minutes or less. I do have ones that go longer when I need to. They do start with music because I like to let them buffer a little bit by playing some music at the beginning, and then it goes into everything I'm doing.
Hi, this is Dr. Dave. Let's take a look at some assignments that were turned in by students for Technology Assignment 2 so you can see how I graded these. So here is the tables and the corresponding graphs here. And the first thing I'm going to look at.
Notice this is for Virginia, not the U.S.
Axes labels, years since 2000, that looks pretty good. The vertical axes, tuition and fees in dollars, that also looks good. The titles look excellent. Virginia tuition and fees at 2-year colleges versus public 4-year colleges down here. Excellent.
So I'll stop that right here. What I'm trying to do is model what they would do if they were looking at someone's poster to say, is that a good graph or not? So I'm going through the different pieces, and I'm also going to explain to them a little bit later on how I can grade them so quickly to know if they're right or wrong. I don't tell that in advance, but I tell them afterwards. And so basically they end up matching up the tables on the top and the bottom. There should be some commonality between them. And once they understand that, it's like, oh, I know how to correct my own, usually is what happens. So one of the things that I find really useful is screen capture software. I do a lot of screen captures. I capture the screen, put it onto the blog, I capture it, I put it into handouts. I couldn't live without that. There are 2 possibilities, I think, for actually doing screen capture. TechSmith Snagit works terrific, but it costs me money, so I don't use it, but I know it's a great product. What I use is something called Gadwin Print Screen 4.6. They have a more recent version, but that one costs money. And to be honest, I've never needed capabilities beyond that 4.6. What I do is I set it up. I can capture the full screen, a part of the screen. I can copy it to the clipboard. I can copy it to a file. And so whenever when I'm creating these handouts, I'm just doing the assignment. And then at certain points, I just hit the print screen button. I scroll across my screen to select the part I want, say, save that, puts it into a file, into a certain directory, and I just keep moving on, and then I go put them back together later on. It's a really simple process. I'm sure you could probably do about the same thing with Snagit, but it costs me money, so I don't use it. So once they've gone through and done all of these different assignments, they have to put together their project. I used to do a written document that had an introduction, a methods section, a results section, and a discussion. And the problem is students don't know how to filter what they've done. I'd have students turn in 15 pages of work, which could have been done in 3 or 4. So I needed a way to get them to not give me as much stuff and start to discriminate between what supports their argument and what doesn't support their argument. And so that's when I went to using these posters. And I have them do it all in Microsoft Office. And it forces them to fit everything onto that poster. And most of the time, that's their biggest problem. They're like, what do I leave out? I want to put it all in. If they created a graph, they spent 10 minutes on it, they want to put it in there. But you know what? They don't need most of them. Usually you just need one graph. That's it. So I like them because when I'm grading them, it's all in one page. I can zoom in, zoom out, and look at the pieces I need. I don't have to page through all the things and look for stuff. Students like it because when they're reviewing it, they can see it all on one screen, zoom in and zoom out on it. And it gives them some creativity. A lot of students take the template I start them with and then go ahead and add some clip art and stuff to that. There's one project where they're designing a solar toaster, and I see so many clip arts of toasters, it's unbelievable. But I also have a website where I explain the process for creating these research posters, and that's what you see down here. So they start from a template that looks like this. It's got some, text that I've just typed in, and basically all they need to do is go change this stuff. And on the first project, that's about all they do. They just go change what's in the columns, paste in some tables, paste in some graphs, the things that they've been doing in the technology assignments, and that's what they turn in. And they end up with something that looks kind of like that. So here's a video that I did for creating those PowerPoints. And this one's like 17 minutes long because there's a lot of steps to doing it. There's a lot of nuances and things. A little different music, it's building up. But it also gives a chance to everything to buffer in.
Hi, this is Dr. Dave. In this video, we're going to talk about how to create your research poster from a template. What you see here is what we're aiming to do.
That's the other thing I always do is say, this is what you're going to end up with.
These are the required sections: the introduction, methods, results, and discussion section. It has a title, your name, and the institution. One of the things you're going to want to make sure you understand how to do.
When you're a student, learning how to use some of this stuff, boy, you want to get every little bit of information you can. So that particular video, I made it with Camtasia. It is basically just screen capture. I'm doing it on the screen. It's being captured and recorded, and then I do a lot of editing in it. And we have some licenses here on campus that we have that you can use. I also have, you can also use Jing to do this, which is the free version of Camtasia. Not as easy to use, but it's free. And a lot of math instructors do screen captures like that. I think there's a limitation on how long they can be. Is that right? 5 minutes, yeah. A lot of mine go longer than that, so usually less than 10. The other thing that I find useful is using the tools that I already have in my office. So every one of us in our office has got Office 2010. And I said most of the time I don't try to give individualized feedback to the students. However, when you're giving feedback on these projects, I want to tell them what all their scores are, how I graded it, all that kind of stuff, and any comments I have for them. I used to use a tablet and go write on these things, circling and save it. It took me hours and hours to do 50-something students. Now what I do, because they're doing peer review along the way, peer review catches most of the major mistakes, especially when I tell them during the peer review, you need to look for this particular thing when you go through these projects. Make sure they calculated the slope right. Make sure they predicted in the right years, all these different things. So they're doing most of the work for me. And then when they turn in their final version, I'm just kind of throwing in little comments at the end as much as I can. So one of the key things is I give them a lot of different grades here. I use a rubric to do it. But as I'm grading these, what I'm doing is I'm using an Excel file. The first 3 columns in that Excel file I've downloaded from the learning management system. And it'll put into an Excel file first and last name, what their email is. And then I go ahead and add these other columns, the draft column, the review column. And I'm giving them scores on each one of these things. On the far right, you see a comment or a column for comments. And that's where I'm actually giving them personalized comments on what they did. Once I've gone through and graded all these things, I've got this beautiful Excel file. What's great about it is if I'm trying to do assessment for my classes, all the data's in an Excel file for me already. Makes it easy to do all my assessment. I don't have to download the stuff from Blackboard or MyLabs Plus. Then I go into Word and I create my email message in there and then do a mail merge. And what I can do is within that Word document, I can paste in the data for the columns in such a way that I can create 50 email messages to my students with the information from each one of the rows in that Excel file. So when they look at it, they'll get an email that says, "Dear Josh, I just finished grading your project 2. Here are the scores that you got." And it'll say draft, review, CU for conceptual understanding, and then it'll give the score there. So they each get individual emails, and it shows the comments down there. For me, that's a faster way to get them feedback than the other ways that I used to do it. It used to be I would leave comments within Blackboard, and they'd have to go click on their score and look at my comments. They don't do it. They don't look at those comments. They look at the score, and they don't really go in and look at everything. So I was spending all this time writing all over these things. No one was ever looking at them. They were making the same mistakes over and over. However, if they get an email, they look at it usually and read it. And so I get lots of responses back to the email. I mean, I sent one out on a technology assignment yesterday, and I had 6 emails back within an hour saying, "I knew something was wrong with that, but I had to turn something in, let's talk about it a little bit." Starts a lot more conversations. So I feel now, I used to spend a lot of time creating content. Now I spend a lot of time creating feedback because I've already got the content stuff there. So I try and, I used to hate to send them email. Now they get an email from me every week with something kind of personalized in it a little bit. And sometimes all it is when I download to an Excel file, I just download some of their scores and give them an update on what their overall score is. Even though they can do it easily themselves and see what their grade is, they often don't think to do it. So I send them an email with that information in there. So if you want more information on how to do a mail merge, I've got a handout like the ones I give to my students on pblpathways.com. That's my personal website. It's got all the projects I do, but it has the mail merge handout as the first blog post right now that's there. And then ycmath.com, spelled W-H-Y-S-E-E math, and why do math, C math done. I figured it was kind of catchy. That's where my students go to get everything for the class. So it's a blog website. I'm posting weekly announcements there and linking to them from my learning management system. All the handouts, it's got the textbook that I'm writing right now, it's all in there. That's where most of my students get their information for the class. All right.